Good morning, ma'am. Myself K. Shivakumar from the Civil Engineering Department. Today I am going to present the performance characteristics of Kaplan turbine. Objective: to conduct performance test on Kaplan turbine and to draw characteristic curves. The student will be able to verify the efficiency of Kaplan turbine from the experiment. Scope: the knowledge on working principle and efficiency of Kaplan turbine used in hydroelectric power plants. Apparatus: Kaplan turbine, test rig, tachometer. Procedure: close the inlet valve and prime the pump. Start the pump gradually. Open the gate valve while monitoring the inlet pressure to the turbine and set it to the deused value. Increase the primary load on the brake datum, say 1 kg. Thus, secondary load gets increased. Measure the turbine RPM using tachometer. Note the pressure gauge reading at the turbine inlet. Note down the orifice meter pressure gauge readings P1 and P2. Repeat the experiment by increasing weights of the hanger. These are the formulas to calculate the efficiency of Kaplan turbine. These are the readings we get during the practical lab in the laboratory. Result: the efficiency of Kaplan turbine is 1.097%. Thank you.
From Civil Secondary Department of Civil Engineering, having pin number 110. Now I'm going to explain about hydraulic jump experiment. The main theme of the experiment is determination of energy loss in hydraulic jump. Aim: to understand the energy loss in hydraulic jump through an experiment. By doing this experiment, we get the knowledge of energy loss in hydraulic jump. Is used for flow measuring devices like a dams, rivers, and other slope areas. To do this experiment, we need some apparatus, whether open channel flow setup, depth gauges, stop bars, etc. First, we want to know about what is hydraulic jump. Hydraulic jump is also known as standard flow. This jump is formed in an open channel when the unstable supercritical flow is nothing but shooting flow. This flow occurs when the Froude number is greater than 1. To stable subcritical flow when the Froude number is less than 1. By this change in the flow condition will cause the flow to critical depth. The water surface slope becomes infinity at the critical depth. The water surface tends to become vertical, which is manifested in the formation of hydraulic jump. The hydraulic jump is occur at where the bottom of the channel changes from steep to mild slope and below the contour structure. Is also formed when the obstruction is formed in the channel. There are 4 types of hydraulic jumps. First thing, angular hydraulic jump, weak hydraulic jump, oscillating hydraulic jump, steady hydraulic jump. The angular hydraulic jump when the Froude number is equals to 1 to 1.7. The weak hydraulic jump, the Froude number is equals to 1.7 to 3. Oscillating hydraulic jump is from, the Froude number is from 2.5 to 4.5. The steady hydraulic jump is from 4.5 to 9. The hydraulic jump is causing the fluid to slow down and increase in height. It is an energy dissipation. The hydraulic jump has some major uses. In the hydraulic jump is used to dissipate excess energy in dam at spillways, preventing the erosion and damage to the dam. In water treatment also, aeration. Hydraulic jump can be used to aerate water, increasing oxygen level and improving water quality. Hydraulic jump can be used in mixing also. Hydraulic jump can be used to mix water and other substances such as chemicals or nutrients. The hydraulic jump is an energy dissipative. It is also used for removing the waste from the channels. We have to know the experiment, procedure of the experiment. First, set up the channel for a given slope. Now, close both inlet and outlet gates. Allow water in the channel. Open the gate 2 completely. Open the gate 1 slightly so the water flows under the gate in supercritical form condition. Close the gate 2 gently so that it causes obstruction to supercritical flow and a hydraulic jump. Regulate the gate to finely that the hydraulic jump stays in the middle of the channel. With the help of traveling hoop gauge, measure the conjugate depth of flow before and after the hydraulic jump, Y1 and Y2. Note the time taken for our level rise for calculating the actual distance. By the figure, we have to know detail about the hydraulic jump. To find out the loss of energy in hydraulic jump, we have to know some formulas. That formulas are velocity before the jump is denoted by V1. V1 is equals to discharge by W into Y1. The units of the velocity is meter per second. Then velocity after the jump is denoted by V2 is equals to Q by W into Y2 meter per second. Then loss of energy, it is denoted by EL is equals to Y2 minus Y1 whole to the power of 3 by 4 Y1 Y2. The units of the loss of energy is meters. By doing this experiment, we have some observations that are first depth before the jump. The depth before the jump is first 0.018 and the depth after the jump is 0.021 meters. The time taken for 10 centimeters rise of water in the collecting tank T seconds when the depth before the jump and after the jump is 51 seconds. When the depth before the jump is 0.022, the depth after the jump is 0.023. The time taken for 10 centimeters rise of water in the collecting tank is 55 seconds. When the depth before the jump y1 in meters 0.021 meters, the depth after the jump is 0.022. The time taken for 10 centimeters rise of water in the collecting tank is 69 seconds. By discharge. First, when the discharge is 1.7 into 10 power minus 4, the velocity is 0.062. V2 is 0.053. The loss of energy is 1.7 into 10 power minus 5. When the discharge is 1.6 into 10 power minus 4, the velocity V1 is 0.048. Velocity V2 is equal to 0.046. The loss of energy is 4.9 into 10 power minus 7. When the discharge is 1.3 into 10 power minus 4, the velocity V1 is equals to 0.041. Velocity V2 is equals to 0.039. The loss of energy is 5.4 into 10 power minus 7. By calculating the given data is depth before jump y1 is equals to 13.6 centimeter. Depth after jump y2 is equals to 13.86 centimeter. Velocity before the jump, that v1 is equals to q by w into y1 is equals to 0.15 meter per second. Then the velocity after the jump v2 is equals to q by w into y2 is equals to, the velocity after the jump is 0.138 meter per second. The loss of energy EL is equals to y2 minus y1 whole cube by 4 y1 y2 is equals to 6.01 into 10 power minus 6 meters. By doing this, the result is the average loss of energy due to hydraulic jump EL is equals to 6.01 into 10 power minus 6 meters. The loss of energy in hydraulic jump is measured in meters. Thank you, ma'am.
Myself, Mallesham, I am studying in MLRITM second BTech second year. I am explaining about the calibration of triangular notch. Objective: to determine the coefficient of discharge for triangular notch. Outcome: the student will be able to find the actual and theoretical discharges and coefficients of discharges. Scope: the knowledge in practical application notches through triangular, rectangular, trapezoidal, and notch experiment. Apparatus: channel with triangular, rectangular notch, point gauge, collecting tank, stopwatch, and scale. Experimental setup: the notch is thin steel plate which placed across a channel to measure the rate of flow of water based on the shape of the crest. Notches are classified into rectangular notch, triangular notch, and trapezoidal notch. Procedure: position the notch plate at the end of the approach channel in a vertical plane with the sharp edge on the upstream side. Admit water to the channel until the water discharges over the notch plate. Close the flow control valve and allow water to stop flowing over wear. Set the point gauge to a datum reading. Position the gauge about halfway between the notch plate and stilling baffle. Admit water to the channel and adjust flow control valve to obtain heads. For each flow rate, stabilize conditions, measure and record H. Take readings of volume and time using the volumetric tank to determine the flow of rate. Formula: actual discharge Q equal to AH by T. Theoretical discharge QT equal to 8 by 15 under root of 2G tan theta by 2 H to the power 5 by 2. Coefficient of discharge Q actual discharge by Q theoretical discharge. Observations: triangular notch included angle 90 degrees, tank length 50 cm, tank breadth 30 cm. Results: coefficient of discharge of triangular notch CD equal to 0.036. Thank you.